All right, guys, here with Mr. Alent, gonna start kind of part B of our 10-6. We were just looking at finding the volume for prisms and applying the formula, understanding the difference between the height of the prism versus like the height of a two-dimensional thing like the trapezoid or the triangle, keeping those straight. And now we're gonna go ahead and look at cylinders. So let's see what's going on with cylinders. And look at the formula up there. The volume is pi r squared h. Here's why I love circular things. Anything that deals with circles. There's not as much information. Like look over here. We had this capital B, which changed depending on what the base was, right? So we were having to find all these different things. And then we still had to multiply by the height of the prism, which we had to keep separate from other heights and all that. With a cylinder, your base is always a circle. So it's always just the radius. I just need r. That's it. I need r. And then for a cylinder, I do need the height of the cylinder, but that's the obvious one. The height of the cylinder is how far apart of the circular base is, right? So it's very similar to here. The height is distance between bases. Same thing. Height is distance between the circles, how far apart of the circles. So the hardest thing is always just finding what r is. Sometimes it's given, sometimes it's a little bit harder. And so here it's not given exactly. We're going to have to find it. What is given is that the circumference of this circular base is 12 pi. All right, so this is going to be a bit of a working backwards problem. Write that down. Working backwards. If you remember when we were working backwards back in chapter 9, you would take the information given, plug it into the formula, and then solve for the missing thing. And so if we're talking about circumference here, I'm going to have to remember the circumference formula is 2 pi r. C equals 2 pi r. When you work backwards, you always write the full formula. C equals 2 pi r. Then plug in what we know. We were told what C is. It's 12 pi. So replace C with 12 pi. So 12 pi equals 2 pi r. So then the question is, what would r have to be to make this 12 pi, right? Well, 2 and pi, this throws people off sometimes. Pi is just a number, guys. So just like anytime, if I want to solve for this variable r, I've got to undo what's happening. Right now, r is being multiplied by 2 pi. So if I divide by 2 pi from both sides, that will get my r alone, which is what I want. Okay? So I have r now, because 2 divided by 2 is 1, pi divided by pi is 1, so they don't mean anything, because 1 times r is just r. And then over here, the pi's will cancel also, right? Pi divided by pi, that's 1 over here too. So those are gone, and then 12 divided by 2 is 6. So it looks like our radius here is going to be 6 centimeters. So there's a little bit of working backwards, given a circumference, finding the radius. And now we have what we need. We can go ahead and apply our formula for the volume of a cylinder. Volume equals pi times the radius squared h. I always write out the formula first, and then plug in what we know. We know the radius is 6, that's going to get squared. The height, again, this h is the height of the cylinder, which is the 18, right? How far apart are the circular bases is your height of the cylinder. Okay, and so what we'll get is 6 squared is 36. 36 times 18 is 648. So this will be 648 pi, right? Multiplying all these and just leaving the pi tacked on. This would be in terms of pi, right? This would be centimeters cubed. Or if we wanted to get it to the nearest tenth, that'd be 2035.8 cubic centimeters. And this just, again, depends on, and we said this several times, right? It depends on, do they want it in terms of pi? So just follow directions for what they ask for, right? In terms of pi versus to the nearest tenth. Or rounded, however. You know, in this case I said to the nearest tenth, but you know, maybe it would say the nearest whole number or something like that. So, okay, there's one example. Let's see one more example of these cylinders. Now, this one, we have to be a little bit careful, right? What is the shape? The shape is not a full cylinder, right? The shape is half of a cylinder. So we have to just kind of keep that in mind. Half a cylinder means you're going to have half the volume, right? You have half of what you would if it was a full cylinder. So we're going to have half of its volume. So we're going to take our volume formula, the pi r squared h, and we're going to go ahead and multiply that in half. So we're going to say like 1/2 times pi r squared h. Okay? And so again, this is what we're doing here. Why there's that half now when there wasn't before. There isn't one in the formula, but we're halving it because we're looking at half of a cylinder. If you want to just find the volume and then cut it in half at the end, fine, that works too. Okay, the height of our cylinder is at 2 millimeters. That's good, right? How far apart they are. Now r, again, r stands for the radius. Be careful here. 0.8 is not the radius of the circular base. Notice the little bracket here. It's going all the way across the circle, so this is actually a diameter. So d is 0.8, which means then r has to be half that, which is 0.4. 0.4 is half of 0.8, so please note, right, radius, which is half, is going to be a 0.4. Okay, let's plug it in. Volume is 1/2 times pi times 0.4 squared times height of 2. I'm not going to put it in terms of pi this time because of this 0.4, we're already going to be in decimals, so we might as well just stick with the decimals, which is going to get us the 0.5 millimeters cubed. All right, kind of funny, right? That all this multiplied out and came out to be just 0.5. That is a 5. Sorry, my 5s look a little funny sometimes. Okay, there we go. I'm going to go ahead and stop the video here. This one was a lot shorter, but we do have 10.7 to go over, and so I don't know if I would fit that into this video. So I'll do a third video now to show you the 10.7 and finding the volumes of pyramids and cones.